Hey, this is Randy, and today we're going to learn how to add polynomials. This topic is actually a prerequisite for many professions in the real world. For example, the engineers who design roller coasters use polynomials to model those curves. Also, civil engineers use polynomials to predict traffic patterns, and that list goes on and on. So, let's learn how to add polynomials. Before we add these two polynomials, let's talk about like terms, and then we'll talk about parentheses. So first question is, what constitutes like terms in polynomials? Well, let's use the example of this first term, 2x to the power of 3. You'll notice that the variable is x and the exponent is 3, okay? Both of those things, the variable and the exponent, need to be the same in order for 2x to the power of 3 to be a like term with another term. Okay, so let's find out in this example, are there any other terms that have a variable of x and an exponent of 3? Well, right here, no, 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 and right here, no. So 2x to the power of 3, or 2x cubed, has no like terms in this situation. So when we start to simplify, we're just going to rewrite this 2x to the power of 3 again because we cannot combine it with anything. What about negative 8x squared? Are there any other terms that are like terms with negative 8x squared? Well, notice we have a negative x squared or negative 1x squared. Those two are like terms because they have the same variable, x, and they have the same exponent, which in this case is 2. What about negative 6x? Well, we also have a positive 6x. Those are like terms because they both have the variable x and they both have an exponent of 1, even though we usually don't write that 1. So those will be combined. And what about 5 and 7? Well, you could think of 5 and 7 in the following way. 5 could be rewritten as 5 times x to the power of 0, even though you don't need to write x to the 0. I'm just going to write it now to explain something. And then 7 could be rewritten as 7 times x to the power of 0. Now you can see that these actually do have the same variable and the same exponent, right? X is the variable and the exponent is 0. So the 5 and the 7 can be combined because they are like terms. Okay, very good. Before we start to simplify this expression, let's talk about parentheses. When we're adding two polynomials, like in this situation, you'll notice that the parentheses can actually be taken away and the expression does not change. So when we're adding two polynomials, we can ignore the parentheses. But if we, hypothetically, had a minus instead of a plus right here, then the situation becomes a little bit more complicated, and we'll talk more about what to do in that situation in a future video. But today, we only need to worry about how to add polynomials. So the 2x to the power of 3 is what we'll write first, and we cannot combine that with anything, so we're just going to rewrite it. So 2x to the power of 3, or 2x cubed. And now we have negative 8x squared, which can be combined with negative x squared. So that's like saying negative 8 plus negative 1, right? Because there's really an invisible 1 right in front of the x. So negative 8 plus negative 1 is like saying negative 8 minus 1, or negative 9. So we have minus 9x squared. Now we have a negative 6x and a positive 6x. So that's like saying negative 6 plus 6, which is 0. So plus 0x, but 0 times x is 0, so we don't need to write that. And lastly, we have a 5 and a 7. So we have 2x to the power of 3 minus 9x squared plus 5 plus 7 is 12. Just like that. So let's make sure that we haven't forgotten any terms from the original expression. This 2x to the power of 3 went directly down, so we took care of that. This negative 8x squared and this negative x squared became the negative 9x squared, so we took care of those. And let's see here, the negative 6x and the positive 6x became 0 because they canceled, so we took care of those. And the 5 and the 7 became the 12, so we took care of those. Now you'll notice that our expression here is already in standard form because the exponents go in descending order. If we had an expression that had exponents that didn't go in descending order, let's say that we had the negative 9x squared first, then it would be important to rewrite that with the terms in the correct order so that the exponents are going in descending order, so that our expression is in standard form in the final answer. So now that we have no more terms in this expression that can be combined, we are finished and we have written the simplified sum of these original two polynomials. So how could we describe the situation in words? Well, we could say add the two polynomials, or we could say what is the sum of the two polynomials. Both of those are correct ways to describe the situation in words. And with that, we are finished with the video on add polynomials. And remember to always be clever.